rules of proof. I want to record a few examples that I'm working through in Carnap. And the point of working through them in Carnap is both so that you'll see some more examples and also so that you'll see how the Carnap interface works in entering proof. So these are going to be examples that are going to involve subproofs. And here are a couple of things to keep in mind when doing proofs in Carnap. So we use the same keyboard substitutes for logical symbols that we've used all along. When writing a line of proof, we need to put in a colon before the rule that justifies the line. So we write in the line, we write in the sentence, and then we put colon, and then we write the rule. So it looks just like the proofs in the earlier videos, except we have to put in a colon to tell Carnap we're shifting from the sentence to the rule. And although there's no rule that justifies a premise of an argument, we write colon PR after the premises so that Carnap knows that they're premises. Now, the new thing in this week is subproofs. And to enter a subproof, you press the spacebar at the beginning of the line. Remember that a subproof starts with an assumption, and there's no rule that justifies the assumption of a subproof, but you write colon AS, and that's just a cue to Carnap to tell it that it's an assumption. So take a look at this proof, or this sentence, this argument. Given G arrow H, we want not H arrow not G. And this is an inference that's sometimes called transposition. Some proof systems have it as their own rule, an extra rule of proof. We don't have it as an extra rule. So it's something we can prove, we just don't have it as a one-step rule. So to set it up, we write the sentence that we have as a premise, and we tell Carnap that it's a premise. Now, I'm just going to leave some space, because I don't know how much space the proof will take, but I know that the last line of it should be not H, arrow, not G. So I ask myself, how could I get that? I mean, I can look at premise 1, the premise, line 1, and I can think G arrow H. There's nothing I can do with G arrow H on its own. So how could I get sometime, somewhere, wherever the end of the proof is going to be, not H arrow, not G? Well, it's a conditional, so maybe think about using conditional introduction. And now the question is, conditional introduction, what does that require? If you remember from the earlier video, or if you look at the reference sheet, you look at the rule for arrow introduction, it requires a subproof. So I press the space bar on line 2 to start a subproof. Notice here, it's put in the new vertical line and a horizontal line, and it's appeared over here in the graphical version too. So in order to use arrow introduction, I assume the left-hand side. And I put colon, capital A, capital S to tell Carnap that it's an assumption. Then, what I want to have happen in this subproof is to get not G. I press spacebar so that I'm still inside the subproof. Well, if you look at the rules of proof, if you remember the rule of proof from an earlier video, you might think, now I can do something with line 1 and line 2. There's a rule called modus tollens that says if you have a conditional and you have the negation of the consequent, you can write the negation of the antecedent. I can get not G, modus tollens 1 and 2. So then I'm done. I don't need to extend the subproof any further. And I didn't need these extra lines, so I press the delete key to pull up the bottom line. And I have a subproof where I assume the antecedent, show the consequent, and that means I can introduce the conditional. So it's conditional introduction to arrow 3. And Carnap says, green, check. that's a legitimate proof of the claim we were asked to prove. So that's all well and good. And if you're not sure about it, you can take your time, compare the rules as they are in this proof to the rules as they appear on the reference sheet. But what would happen, here I have the same problem set up. What would happen if you didn't remember the modus tollens rule? So start out in the same way. G arrow H, colon, capital P, capital R, to tell it it's a premise. And then we think, not H, arrow, not G, plan to use conditional introduction. Okay, back up here, line 2, I press the space bar to start a subproof. I assume not H, colon, AS, to indicate that it's an assumption. So it's capital A, capital S. And then spacebar, so I'm still inside the subproof. I think, I don't know. Like, what could I do that would get not G here at the end of the subproof? I'm now thinking, I'm leaving space because I'm not sure what the steps will be. How can I fill in the space so that down here, whatever line number this ends up being, I get not G? Well, not G is a negation. So you might think, well, could I do negation introduction? And so if you have this thought, it's a perfectly good thought to have. You look at the reference sheet and you see that negation introduction requires a subproof. And that means back here on line 3, we'd have to start another subproof. We'd assume G, and inside this subproof, what we need is an explicit contradiction. We need to get a sentence followed by the negation of that same sentence. Well, looking at what we have on lines 1 through 3, you notice line 1 and 3 actually work together. We can get H by arrow elimination, 1 and 3. Staying in that subproof inside the subproof, we can get not H by repetition of line 2. And that's actually it. We have on line 4 and 5 an explicit contradiction, which is what we wanted in this subproof. This one that runs from 3 to 5. So on line 6, we can say negation introduction, not G, applied to lines 3 through 5. So back out in the main proof now, we had a subproof where we assumed not H, we got not G. That lets us get not H, arrow not G, by arrow introduction, 2 through 6. And again, Carnap says green, check mark. Now, if we compare these two proofs, the first one where we notice the modus tollens rule, modus tollens is a derived rule, so if you don't notice it, you can always prove provable claims without it. And the second one, where we didn't notice the modus tollens rule and instead used negation introduction, they're both perfectly legitimate answers. This first one is simpler, kind of. The second one does something we haven't seen before, but which was completely allowed in the proof system, which is a subproof inside another subproof. So we started this first subproof to do conditional introduction, and then because we wanted to do negation introduction, we started a second subproof inside of it. So either of these is a perfectly good proof. If you look at the reference sheet, you should try to understand why it is that the steps are allowed. But if you were asked to prove this claim in homework or in an exam, either of these would be correct answers. Either of these would be full credit answers because they start with the premise, they get to the conclusion, and they follow the rules of proof all along the way. Okay. Here's another example. I'm going to do, again, you can sort of see how I've set this up. I'm going to do it twice. Given not P or Q as a premise, we want not Q. Well, you might think, okay, I want not Q. How can I get it? Maybe I could do negation introduction. It's a natural thought to have. And when you look at the negation introduction rule, if you look at it in the reference sheet, it requires a subproof. So back up on line 2, I press the space bar to get a subproof, and I'm assuming Q. And what I want is an explicit contradiction. I need to find some sentence followed by the negation of that very same sentence. So on line 3, I hit the space bar again to stay inside this subproof. And there are various things you could try, but here's one thought. I can get P or Q from line 2. What rule do I appeal to? Well, it turns out disjunction introduction or introduction lets you introduce a disjunction where one of the disjuncts is a line you have earlier. So given Q, I can introduce P or Q. On line 4, I hit the space bar to stay inside this subproof, and then I just repeat line 1, so colon, repetition, line 1. Here I have an explicit contradiction. I've got this sentence, P or Q, and I've got the negation of that very same sentence, not P or Q. So I don't need to continue the subproof. It gets what I want, because I can now do negation introduction based on the subproof on 2 through 4. Carnap isn't happy with that. What isn't it happy with? Oh, this is the trick. So Carnap has this exclamation point here. It doesn't like line 2. It's here, if you look at it, it says expecting a rule citation. And here's what I did wrong. Back on line 2, I just wrote Q. Carnap, remember, needs to see :AS to remind Carnap that this is an assumption in a subproof. It's totally legitimate to write there, but I need to tell Carnap it's an assumption. So if you were thinking I should do that, I missed it. But Carnap's error message allowed me to figure out that that was what I needed to add. So this is a complete proof. And I've set this up because I'm going to do this a different way. I'm going to show you that there's another way to do this proof. And again, when you do proofs, you're only asked to do it one way. I'm doing it multiple ways, both so you see different strategies, and maybe you find one of them more natural than another. I've set up the proof in the same way. You might look at line 1 and remember that there's a rule. It's a negation of a disjunction. It's a not or. There's a rule here. And in fact, if you see a sentence like sentence 1, you should have this kind of reflex. Hey, maybe I should use De Morgan's rule on that. Because De Morgan lets me turn that negated disjunction, which isn't very useful, into a conjunction where the two parts are negated. So it lets me turn it into not P and not Q. And that's something that's easier to work with. The justification is De Morgan's rule on line 1. And now we want not Q. We can get that directly from line 2. Because and elimination just allows you to pull out either of the conjuncts, either side of the and sentence. And we have not Q here, so we can just write down not Q by and elimination. So the second proof avoids having to have a subproof because we noticed that De Morgan lets us turn that premise, line 1, into something that's easier to use. But again, either of these is a perfectly acceptable full credit answer, if this were a question that you were on an exercise. Either of these is a perfectly good proof. Okay. I'm going to work one final example, and this one I'm just going to work one time. And this one's a proof of a theorem. You can kind of ignore this T that Carnap puts on the left-hand side. But what it means is that we don't get any premises. So there's nothing to write on line 1. I'm just going to leave some space. I don't know when the proof is going to end, but I know that what needs to be on the last line is K arrow, not, K. And the question is, what could I do that would let me write that down as the last line of the proof? It's a proof of a theorem, so I'm going to need a subproof of some kind. Since line 8, or it's the last line of the proof, is a conditional, it's natural to think of conditional introduction. So if I plan to apply conditional introduction, back up here at the top, I press the space bar to start a subproof. And as the assumption of that subproof, I'm going to assume the antecedent to the conditional. I'm going to assume K. And what I want to have happen is not K. I'm going to leave some space. I don't know how much space it will take, but so at the end of this proof, I need to get not K. And the question is what I could get it from. So one thought you might have is, that's a negation. Could I do a negation introduction? And the answer is yes. If we follow the negation introduction strategy, we're actually going to end up with 5 subproofs nested one inside the other. So if you want to avoid more subproofs inside subproofs, you could ask yourself, what other patterns are there in line 7, besides just the fact that it's a negation sentence? Well, one thing is that it's got a bunch of negations in a row, and we have this double negation rule that lets us remove a pair of negations next to each other in a sentence, or add a pair of negations next to each other. So if on line 6 we had not K, somehow, if we could get that somehow, then on line 7, double negation would let us write down 4 nots and then K. But we can get not K, again, by double negation, but now just from line 1. Like we already have K, we can add 2 negations to it. So we don't actually need this extra space. In the subproof, we start with K. We add 2 negations by double negation on line 1. Then double negation on line 2 gives us 4 negations and then K. That's what we wanted to end up with in the subproof. So back out in the main proof, we conclude K arrow not K by conditional introduction on that subproof, 1 through 3. So that's a proof of a theorem. It's something where we don't get an assumption in the main proof. We don't have any premises. And so you have to start a subproof. And the subproof requires looking ahead to where you want to be at the end and working backwards with a plan to apply either conditional introduction or one of the negation rules or biconditional introduction. So hopefully these examples have helped both in thinking about proof strategy and thinking about how the rules work, but also in seeing how you format and type proofs into Carnap. I have to admit, Carnap takes a little getting used to. You notice I made an error earlier. But if you have questions, reach out and ask. because being able to do proofs, it's not a magic trick. It's basically, it's learning how the rules fit together, and then by trial and error, learning the patterns and seeing what patterns you can use to get from the premises, if there are premises, to the conclusion, or to set up a subproof, which lets you get the conclusion in the case of a theorem. All right, again, there's a study session, there are office hours, I'm available by email, there's an Ask a Question forum, reach out and get help if you're having trouble with it. But there's also the Proof Playground area, which is an area in Carnap, there's a link to it from the Blackboard page, where you can just try out proofs. You can try fitting together proofs and see how they work. So explore, try it, and good luck.